All right, here's another think, pair, share. This is about smartphone users. So in the United States, the ages 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation 36.9 years and 13.9 years, respectively. Determine the probability that a random smartphone user in the age range from 13 to 55 plus is between 23 and 64.7 years old. Okay, so let's put down our givens. That's always helpful. So let's see here. What we're looking at is we're looking at mean and standard deviation of 36.9 and 13.9, and it's normally distributed. And we're looking at age of smartphone users. So age of smartphone users is our random variable. It's normally distributed with a mean of 36.9 and a standard deviation of 13.9. Okay, so let's go ahead and maybe draw that. Just do your best to sketch it. So we have a mean of 36.9. And let's use the calculator here really quick. So 36 plus 0.9 plus 13.9. That gives us 50.8. Let's go another 13.9. It gives us 64.7. Let's go another 13.9. 78.6. So yeah, too much for me to do in my head. All right. Now let's take 36.9 and let's subtract standard deviations from it. All right, now this is going to get us below 0, but I'm just going to put it in there anyway. Okay, because you can't have a negative age, right? All right. So we want to determine the probability that a random smartphone user is in the age between 23 and 64.7. All right, so what's the probability that a smartphone user is between 23 and 64.7 years old? So we're trying to find probability, which means we're trying to calculate area. And so we want the area between 23 and 64.7. Well, wouldn't you know? 23 is exactly one standard deviation to the left. And remember our empirical rule, where between -1 and +1 standard deviations, the area is 68%, which means this area is half of that. So this area here is going to be 34%. All right. And this number of 64.7, well, that's standing right on top of the mean plus 2 standard deviations. And if we look at the empirical rule, that's going to be approximately 95%. So this area here is going to be half of 95. that's going to be 47.5. That's this area. So I'm going to expect that this probability is going to be somewhere close to 0.34 plus 0.475. So, so it should be close to 0.815. Should be close to that. So let's take a look here. Yeah, why not? Okay. So let's do inverse norm. Actually, not inverse norm. We want to do normal CDF because we're trying to find an area. Okay, so the lower value, I believe, was 23. The upper value was 64.7. The mean was 36.9. Standard deviation was 13.9. And there we go. We get 0.8186. So we get a probability of 0.8186, which is 81.86%. So is this value of 0.8186 close to 0.815? Yeah, that's pretty darn close. So with this close approximation, remembering the empirical rule, I was able to kind of deduce what my answer should have been close to and kind of give me an idea of what to expect. So that worked out pretty good here. All right, let's look at part B. So determine the probability that a randomly selected smartphone user is at most 40.8 years old. Well, let's kind of redraw our distribution here. It's always good practice. Something like that. 36.9. And let's go 3 standard deviations up, 3 standard deviations down. I'm just copying from what I did already above. Okay. Now it says at most 50.8. So here's 50.8. And at most means we want everything below that. So we're trying to find an area. So when it says determine the probability, remember, probability is area. So what's the probability that a randomly selected smartphone user is less than or equal to 50.8 years of age? What is that area? So we can kind of use some of the logic from before, that this half here from the mean to 1 standard deviation, that area is 0.34. That's from the empirical rule. And the other half, we don't need the empirical rule for that, because what's the area of half? It's 0.5. So this should have an approximate area of 0.84. Should be pretty close to that. So let's go ahead and maybe do that calculation. Let me back out. So I'm going to use the numworks calculator here. But I have to put some new values in. So 36.9. So 36.9 for the mean. And what was that? 13.9? Yeah, 13.9 for the standard deviation. And we want the area to the left of, what did I say? 50.8. And it's 0.8413. So that comes out to 0.8413. And that's 84.13%. Does that match our expectation of being close to 0.84? Yeah, it does. So that looks right. Okay, the next one. Find the 80th percentile of this distribution and interpret it in a complete sentence. All right, so um, let's redraw this. Again, I know redrawing this might feel tedious, but there's no substitute for getting this stuff into your brain than to have that kind of brain-body connection, your brain with your hand, actually writing it out in front of your eyeballs. There's this feedback mechanism between your brain and the outside world that just can't be substituted than doing it manually. It really helps. All right. So we're trying to find the 80th percentile. So that is indicating that we have an area, and what we need is some value on the horizontal axis. We need a percentile rank. All right, well, where's the 80th percentile going to live? Well, let's use the previous example here. So we know that this half is already 50%. And we know that up to the first standard deviation above the mean, this half is 0.34. And when I added it earlier, that was 0.84. So we'd expect an area of 0.8 to be just shy of this one standard deviation mark. Should be right about there. Should be just shy of that. So this value of k is going to be pretty close to 50.8, but it's going to be lower than that. All right. All right, so we're starting with an area. So this means we need to use an inverse distribution function. All right, so using our calculator, um, let me use TI-83 here maybe this time. But I'm going to use my program. So we're going to use inverse n. And so the area that we want is 0.8. And we have a mean of 36.9, standard deviation of 13.9, if I remember correctly. And we want the area to the left. So we have 48.5985, or rounded, 48.6. And 48.6 is reasonably close to 50.8, and it is a little bit underneath it. So that fits our expectation there. All right. So that concludes that think, pair, share. All right. Let me know if you have any questions.